Hello, and welcome to another in Mr. Haynes' amazing explorations of mathematics. Today's objective, as you guys are going to see, is that we're going to first make sure to put the date and the week in our notes. And our objective is to understand and use the Pythagorean Theorem to find the lengths of legs on a right triangle. Now, one of the questions that I've gotten a lot is exactly what is the Pythagorean Theorem used for? And it's again used to find the lengths of the legs on a right triangle. Now, before we even get to any one of my examples, I actually want to switch screens and show you guys exactly what I mean by Pythagorean Theorem. Now, here we see the Pythagorean Theorem describes the relationship between the legs of a triangle, the lengths of the legs, and the hypotenuse of a right triangle. Now, this is one way of writing it. And here we see the leg of a right triangle is here given by A. Here's the symbol for a right angle, and the leg of the right triangle is B. And the hypotenuse, the one that everyone loves to spell, the hypotenuse is actually just the longest side, or here they describe it as the side that is opposite the right angle. Now, what this relationship means is very important, and in order to understand what it is, I'm going to scroll to this visual example of the Pythagorean Theorem. Now, here, what we've done, and again, when we see it, we see squares of the lengths of the sides of the legs. So here what I've done is in purple, you see that A squared is the area of the square. Here we see the square that has the length of side A. And if you count with me, you know that there are actually 9 squares here in the area of side A. Extending that, we see here that the length of B was 4. And so here we have 4 times 4, or 16 square units in the area of the side B if we square that area. Again, these are just squares. Now we know that 9 here for A squared plus 16 for B squared, 9 plus 16 is 25. And so here, if we look and we count the lengths of the sides of C squared, or the hypotenuse, we have 1, 2, 3, 4, and 5. And of course that's a square, so there are 5 here. 5 by 5 is 25. Again, 9, which is 3 times 3, or the square of leg A, plus 16, which is the square of leg B, leads us to 25, which is the square, or the area of the square of C squared, which is the hypotenuse. Now, we're never looking for the area of the square. Usually we're just looking for the length of a side, and that's what our objective calls for us to do. So here, as you see, as I switch back to the video notes, I'm going to find the hypotenuse for this right triangle. Now, I'm going to shade in side C, which is the hypotenuse, and I'm going to look to use the formula C squared is equal to A squared plus B squared. Now, this is a different way of writing the Pythagorean Theorem, but it's no different. I'm just showing that I'm finding C, so I'm putting that on the left. I need to make sure that I know what the lengths of each side are, so I'm going to label 6 as side A and 8 as side B. So as you see me continue, I now substitute into the formula, and I have A is equal to 6 squared, and B squared is equal to 8 squared. So as I continue with the work, I know that C squared is going to equal 6 times 6, or 36, plus 8 times 8, which is 64. Gotta make my notes look neat. There you go. Alright, 36 plus 64. C squared is equal to 100. Now, I don't want to go, again, just here, you see me using the square root symbol. Now, the reason that I use the square root symbol, as you see here, if this was 6 and this is 8, then the length of the square, if I extended this out, the area of that square would be 100 square units. Just as we saw in my original example, how I had 25 square units. Really what I want to find, see here's 5 times 5. What you're going to see me explain in my video notes is what I'm really looking for is what two identical numbers multiply, and you're going to see me add that in. It's going to have to be identical. The identical numbers that multiply to make 100. There's a lot of numbers that multiply to make 100, but only 2 are identical. And of course, C would then equal one of those numbers, which is 10. 10 times 10 is 100. So I know that the length of this side, C, is 10 meters. All right. So we're going to extend this now, not just the hypotenuse, but now we're going to find the leg. Now, the coolest part is that, A and B, for the legs, they really don't matter. They don't matter. They don't matter at all. And here's why. As you see, like this triangle as it is right now, it's kind of like upside down or whatever you want to call it. But really, this could be the bottom or this could be the bottom. It doesn't matter how I turn the triangle itself. So what I'm looking for is, I can always say that I'm looking for B. So I'm just going to call 5 inches A and this missing side B. And here I know the hypotenuse, which is 13, or C. So I'm going to use a different formula here. Since I'm searching for B, or the length of a side, the length of a leg, I'm going to say that B squared is equal to, I'm going to make a mistake. I got to erase. See, B squared is going to be equal to the hypotenuse squared minus the leg squared. So I have C squared minus A squared. Then all you're going to see me do as I continue this work is I'm going to substitute in 13 for C and 5 for A. Through the magic of television. And an eraser. I've got C, which is 13 squared, minus A, 5 squared. So B squared is going to equal 169 minus 25. Now, I'm going to again go back to my original example. If I was trying to find the length of B, which is here, really what I'm doing is I'm taking this square area, 25, and I'm subtracting this square area, which is 9. So in this example, 25 minus 9 would give me 16. And I know I have to make that into a square, so that's how I know what the square, what the length of side B is, because it's the square root of the area. So back to the notes, you see I have 169 minus 25, so B squared would equal 144. And again, I'm always looking for what two identical numbers are going to multiply, in this case, to make 144. So we all know that 12 times 12 is 144, so B is going to equal 12 inches. And this is a small review of the Pythagorean Theorem. So in summary, in your notes, I really want to make sure that you guys know what the Pythagorean Theorem is used for. So if you have to rewind this video to find out, please do. And really, what can you use it for? How do we use it to find the hypotenuse? And how do we use it to find the leg? What are those two formulas? Make sure you have them written down again in your summary, and that you are starting the practice that you already have at your desks. Please thank you for your attention. And as much as I like talking about math and watching you watch and take notes on a video about math, I love to see you actually doing the math. So, thank you for your attention.